talking about responsible AI. So definitely the first aspect is AI fairness and how you build a system that can where we know what the bias is and how do you measure a bias. This other aspect of responsible AI. Now let's talk about what are the five tenets of responsible AI that I mentioned earlier. So the first one is reproducibility. So this is again along with the Google research paper that we saw. We want to standardize the machine learning process and build an MLOps pipeline. And some of the patterns that are used for this is something like a data catalog. Many times you have the data scientists work on a CSV file and show some amazing results, but then the other data scientists cannot reproduce it. I mean, they basically use Git to share these files, but as the file size increases, this kind of is a constraint for them. So there's a pattern coming up of using a data catalog. There are tools like DVC, data version control, and I'll show an example of that. That can help you. That can help you uh, uh, that can help you version the data and so that all the data scientists are working on the same version. The same thing goes for model. There is a pattern called model catalog or model registry, by which once you train a model, you can check it into that, and now that particular version, that model version is running at a particular location, and you can uh, so you can reproduce the results. Same thing, the next big area is transparency. Here we talk about interpretability and explainability of models. Interpretability typically means your model is inherently explainable. So something like a random forest, you know, based on what it has learned, it can give you the ranking of the features. It can tell you why a particular decision was made. Explainability comes into play when the models are it's more like the black box models. You kind of either have a surrogate model or some other technique like a SHAP scores kind of a technique, which will help you explain a black box model. And then fairness, we talked about a lot. How do you maintain fairness? So transparency is the second aspect. And the third aspect is accountability. How do you make your AI systems policy driven? When do you bring a human in the loop? And what metrics, what monitors do you have to the system? So in this workshop, we'll talk more on these three areas. The two other aspects which we won't talk much, but which are equally important is security and privacy. Security is to make your machine learning model more or AI system more secure, so that now you hear a lot of things about ML systems being attacked, adversarial learning, adversarial attacks, and can you encrypt your model so that even during inference you keep the entire model and the data encrypted so that the results are not shared and there is no leak of the data. And privacy becomes all the more important in today's world with so many data with the GDPR in Europe. It's a major regulation which mandates privacy of AI/ML models, and there are techniques like federated learning and differential privacy which help you achieve this. We won't talk a lot. I mean, my team actually works a lot on these two areas. So if there are questions, I can take it offline, or you can connect with me on LinkedIn. But for this, I'm focusing more on the three areas: reproducibility, transparency, and accountability. So what I'll do is in the remaining time, I'll take a scenario where we'll show a general ML pipeline and we'll apply these principles of reproducibility, transparency, accountability to that, show how that is applied. Then we'll take a break and we'll come back, and then I'll show the couple of demos which actually where you can see this in action. So let's start. So first, this would be a typical way of how the current MLOps kind of a cycle would be. Your data scientists will have a development environment. You'll be doing the data preparation. You'd build a model using, I mean, typically Python is pretty preferred, but the same thing applies to R or any other languages. You could do the testing and validation of your model. And once you are satisfied, so you typically test for your statistical performance. You either do like this confusion metrics, you build a receiving operators, characteristics, ROC curve, and different types of other metrics, and you check the statistical performance of your model on your training data and validation data. And then once you're happy with that, you deploy that to production. The model gets deployed in a production environment. There is a production serving engine. In today's world, yeah, microservices approach is getting very popular. So you package the model as a Docker container or a microservice and deploy it. And then there is some logging provided by the ecosystem where you're deploying your model. And then typically you do service level performance where you monitor the performance of the service. Like if you have deployed it as a REST service, you would see how many inference calls did it receive, how many times it was down, how many times there was an error. So it is more of a health and a service level performance that you do. Not a lot, not always you kind of get into the actual details. Like, is your accuracy is good? Is your accuracy improving? Is the data that you are supplying to for inference, is that having a drift? Now that is what is important when you're looking at ML model, because a lot of times what happens is you're happy with your the data scientist is happy that the model has gives you good precision recall on the training and validation data set. But once you put it in production, the results are not that great. And the reason is you are not really, your production system may be out of distribution compared to your training data. It may not be a good representation of production. So there are several cases. So it is important for you to monitor your production and then at the right time trigger a retraining of the model and collect the right data so that your development environment becomes a representation of production. So let's see some ideas. And again, I'm saying this is not something set in stone. I'm sure you guys may even come up with a better way of doing this, but these are some ideas to bring in reproducibility, transparency, and accountability to this system. So first, let's talk about reproducibility. So here, what we could do is, instead of having like a CSV or a central database for getting your data, and each data scientist, typically this is a multi like a network environment where multiple data scientists work on. Instead of having multiple data scientists kind of just access CSVs, you could have a data catalog pattern here, where you define that this is the version of the data that you want to work on, and your data scientist can take that version of the data, pull that version from the repository, and build a model on that. So another data scientist can compare to a similar to the same version, and both are working exactly on the apples to apples comparison data set. Now there is the modern systems are also talking about feature store, because you take the raw data from one of these data catalogs, then you apply a lot of feature engineering to it. You either do a label encoding, you do a data cleansing, removing NAs. So a lot of feature engineering goes into it to clean the data and make it available for an ML system. So another pattern that is being very popular is using a feature store, where after the data is cleansed and the features are extracted, that is checked into a feature store. So instead of a data catalog with your raw data, you store your features into a feature store, and the same features are used for your training as well as for your inference. So now there is a very uniformity in the way of the model of the data. The same patterns are applied to both, so that becomes very standardized. And the third one is the model catalog, or we can call it model registry, where once the model is created, instead of just saving it as a pickle file or a save file and then shipping it on a putting it on a GitHub server, we have a formal model registry which maintains the versions. So these binary files are checked into the model registry, the versions are maintained, and then when you do the production deployment, you directly take the model file from the repository and do a deployment. So this is analogous to how a software deployment will happen in an agile world. In the DevOps world, you would have a Jenkins pipeline, which will once you check in your code, the pipeline will be triggered and it will take in the right version of the code, that particular branch, and the executable for you, the continuous integration, and then deploy that executable into production, continuous deployment. So the same thing, same patterns we are applying to machine learning. The only difference is here the focus is a lot more on data. You need to version the data, not just your code. And then model is a very important artifact. You don't have just an exe which is being which has to be developed again. You can have the same model, the same binary file which you develop, the data scientist develops, that can be put in a model catalog and reused when you're deploying it to production. So that is about reproducibility. So that will bring some amount of reproducibility to your ML lifecycle. Now, what about transparency? So one way to introduce transparency is you look at you look at explanations as well as metrics. So the data scientist looks at the metrics like your ROC curve, but at the same time you have a pipeline, and I'll show an example of that. pipeline that will also generate your explanation. So once the model is developed, why is the model making a decision? So you can have a like a feature important chart like this. This is generated using SHAP. SHAP is basically a Shapley Global Explanations Library. It uses game theory. I mean, what it does basically is once the model is there, for every prediction, it will assign some SHAP score to each feature and a SHAP score to the output. So you know which feature is giving importance. So this kind of a chart is a global chart, global explanation by combining the shared features of all your training data. So you know that the first feature here, in this case, it's credit history, is more important while making a decision compared to some of the other features. So explanations is something you definitely want to track. We talked about fairness. You want to include fairness matrices here so that you can you know that your data set is not biased. In fact, there's a school of thought that you should have the fairness metrics right in the data catalog or the feature catalog itself. So when you before you check in a data set into your data catalog, you want to do the fairness analysis also. Make sure the data set is fair. Otherwise, you may want to debias the inputs and take the data. I mean, this is something that is also being discussed in the industry. And then the transparency doesn't have to be limited at the data scientist level. It needs to be in the operations level itself. So more than the service performance, what you really need is a data and a concept drift kind of a measurement. So data drift is basically when your feature set is changing. So in this case, you had say a male to female distribution where there was almost an equal acceptance and equals rejection. But in this case, you see there was a greater acceptance of males while less acceptance for a female. Now, these are the things that can help you find bias, but at the same time, they can also tell you that your data is drifting. That you build a machine learning model considering a particular distribution of data, and now what you're seeing is that data distribution has changed. So your model may not perform in the same level that it was expecting, and this could be the reason why it is not, why the model will be failing in production. Now, if the model is really built very well and your training samples are pretty, the training coverage is good, the model may still be able to pick up the on data drift and give the right predictions. So the second part that comes into play here is concept drift. So concept drift is when the relationship between your features and your target changes. So, and this was a prime example of this during COVID, this unfortunate COVID time. We saw pattern of purchase change. Like everybody was working from remotely, working from home. They were doing a lot of online shopping. So the pattern of way the sales would happen in a brick and mortar store versus online totally changed. So there was a data drift. There was at the same time there was a concept drift. So a lot of the prediction models that were built didn't really work. So that's the concept. That's the thing about concept drift. We talked about reproducibility, transparency. Next, and the last part, and which is probably the most important, is I mean, you can do this in libraries technically. You can put reproducibility, transparency, but the key thing is you really need accountability. So what we really encourage to our customers is have an AI ethics committee, and these sets the ethics principles. I mean, you must have seen Google, Facebook, Microsoft having these AI ethics committees or releasing AI principles. But what they really need to do is one is put some policy decisions, like at what level do you say that your model is drifting? Does when the accuracy falls at 80% or 70%, is that considered a drift? And then you ask for a retraining. And then you need to do auditing of these matrices. I mean, all these metrics, it's nice to see them, but you need to have some formal report which is presented to a ethics committee where you can say, okay, this is how your model is performing this week or this month. And the same thing goes with fairness reviews, because you may be at a risk where your model is actually biased, though you didn't really you are totally not aware of it. You want to do this fairness analysis. Some of these things like statistical parity difference and equal opportunity odds, you want to put them in an audit report and have a fairness review occasionally about your performance of your model. So these are like just some ideas I wanted to share with you on how to do reproducibility, transparency, accountability. And I do have an example where I'm showing some of this. So after the break, I'll show some couple of Jupyter notebooks, and we'll take an example of a data scientist. We'll train a model and show how we can introduce reproducibility and transparency, and then see when that model gets deployed to production, how we can monitor data and concept drift. So I think once you see that, I mean, if this was not very clear, I think that will also make things much more clearer. So before getting into the next part, I just wanted to take a break here. I mean, there are a lot of ideas here, and I don't know, some of you already may be working in these areas. So I just wanted to take a break. Any questions on this?
There is one question, Doctor,
Yeah.
by Claudio Cimarelli. I will read for you. I would like to ask you if Kubernetes is a tool that can support federated learning and your point of view of maintaining a Kubernetes system versus other orchestrators. Example given, Nomad is the only other I know of.
Also, I'm sorry, I missed the last part. What was the last sentence?
The
Okay,
last
maybe.
sentence is Nomad is the only other I know of.
Oh, no, but oh, okay. Yeah. So the two questions, two parts of it. So regarding federated learning and Kubernetes, yeah, that's an interesting concept. So the key about federated learning is you want to keep your data local. You want to train the machine learning in a decentralized manner. So Kubernetes kind of tries to centralize things. So you kind of have this like there is a central management of your Docker containers. I mean, to my knowledge about Kubernetes, uh, and they can be. I believe they can be managed remotely. So by itself, it is possible. It's definitely possible to build a federated learning architecture on top of Kubernetes. But then, do you really want to do that? I mean, that's the thing of what is the objective of it. You would rather probably have an aggregator on Kubernetes, which will be managed by Kubernetes, and then your edge node, because the whole point is to keep data local. So you may not even want to have a dedicated connectivity with your local nodes, and have an agent run which will do the local training. So you do in federated learning, you have this different party nodes where you do the local training and send your weight updates to a central aggregator, and the aggregator will combine these updates and run the analysis. So the key point there is you don't want to share your data with the central party. So you definitely you can build it, but the only way, I mean, the advantage I could say is performance reasons, that you want to keep the data on those clusters and not share the performance. But otherwise, you may want to keep it. I mean, to take the true advantage of decentralization, you want to keep them as a separate nodes, where you could have Kubernetes running the federator and running your the parties running either their own Kubernetes or their own Docker. Now, the other you mentioned about, I think, Norbert. Yeah, I'm not very familiar with it. I know Kubernetes in the industry, at least, it's kind of become the standard. There are a lot of managed Kubernetes. Like we have this open data, Red Hat OpenShift, which is more of a managed Kubernetes. So yeah, I don't know about the other technology that you are referring to, but I think Kubernetes is something that is standardized a lot. Did that answer the question? I'm not sure. I could. Okay, let me know in chat if there was uh, if there's any follow up on that. Uh, so one other thing. So these are the so this was the same thing we talked about, a machine learning pipeline. The different aspects like data management, model deployment, life cycle, and production deployment. And these are some of the tools that are currently mostly these are open source tools which are heavily popular in the industry. Things like DVC for building a data catalog, your Feast or Hopsworks for a feature store, MLflow for tracking your experiments. Of course, I'm sure you are familiar with Jupyter Notebook. There is Alibi Detect and Evidently.ai. Evidently is a new startup. I mean, I'm pretty impressed by them. They have this nice tools to do a classification report and data drift. And then the production deployment, Seldon is very powerful that it can do your model A/B testing, multi-arm bandit things, and then integrating with your regular software lifecycle with Jenkins and Kubeflow. And Yeah, so this was kind of some of the tools, and since it's 6:16, let's take a break for 10 minutes, and then once I come back, I can show